Set yours to the middle one to rest. Okay, let's do the long one. See what the period is for that. Okay, and we'll do the same thing. And this one is going to be quite a bit longer. All right, let me start this. I better move over here. Okay. Ready, and 0. 1, 2, 3, 4, 5, 6, 7, 8. Come on, baby. 9, 10. Stop. What do you got? Young lady with the sunglasses on the top of your head. Come on here. Yeah, dude. She doesn't have a watch. You were looking at it like you had it. You know? Okay, Army man. ROTC man. 20.3. Okay, write that down. Someone else on this side that hasn't given me a data. Okay, right next to it. 20.2. Okay, somebody from the slacker side. Okay, up here. 20.3. Good. And one more.
I have 19.84.
Ooh, 19.84. All right, that's a little bit low. That means you jumped it a little bit, maybe. Cat-like quickness. Okay, add those up and divide by 4. What do we get? It's going to be about 20.1 or 20 points. And let's let these two Daniels sit down there and let's give them a hand. Here's the formula for the period of a pendulum that's swinging back and forth with a fairly small swing amplitude, so 10 degrees or so left and right. Pendulum 1 and 2, you can actually calculate this out. You know, you take out your calculator and so forth. L is the length of the pendulum in meters. So for us, it was 50 centimeters or 0.50 meters. Denominator is good old 9.8 meters per second squared. And then you take that quotient and then you square root it, multiply by 2 pi. And that works out pretty close to what we observed and calculated for pendulum 1 and 2. Now pendulum 3 is longer, so I'm going to put a factor of 2 up there. It was twice as long, about 1 full meter. And it took more time to make 1 full cycle. One way to think about this one is, you know, you can put 1.00 in the numerator, divide by 9.8, then square root it, multiply by 2 pi. But another way to look at it is simply to factor out that 2 and smuggle it outside the square root. Here's what it looks like. And so you can see that on the right there, or actually in the middle here, you have 2 pi times square root of L over G, and that's the period of pendulum 1 and 2. But you also have multiplied by the square root of 2. That's a number, it's about 1.41, so you have a longer period for a longer pendulum. And if it's double the length, it's square root of 2 times the period of the initial pendulum.